My name is Yap Yuan Sen, matric number 157853, and I'm a first year student from Pure Physics course, School of Physics. I'm a presenter in this video.
My name is Gayle Wong Yan. I am a first year Pure Physics student from the School of Physics, and I am the scriptwriter for this video.
My name is Liew, and I'm the first year student from School of Physics with program Geophysics, and I'm the video editor for this video.
Malaysia, where the weather can often be described in just one word: hot. In fact, Malaysia receives around 12 hours of sunshine every day, which average out to 4,500 kilowatt hours of solar radiation per square meters. That's enough energy to power an air conditioner for 1,500 hours, which is equals to 2 months if you're wondering. Question is, how do we harness this energy? So, solar energy. And we all heard about it. But how does it work? For that, we need to talk about photovoltaic. Photovoltaic is the direct conversion of light to electricity at the atomic levels. This occurs is due to an effect as known as photoelectric effect. Let's hop into the history class to learn more about photoelectric effect. In 1839, French physicist Edmond Becquerel noted that the certain material will produce a small amount of electric current when exposed to light. To put it simply, the material would absorb photons of light and release free electrons, which will register as electric current. Albert Einstein then further expanded on this observation in 1905 when he described the nature of light and photoelectric effect, which he would later go on to earn a Nobel Prize for. And this theory formed a basics of photovoltaic technology, and the first photovoltaic module was finally constructed in 1954. But at that time, it was still too expensive for general usage, and the technology only saw further implementation during the space race in 1960s. Where, you ask? Rockets, of course. The research and development carried out by the space program helped to advance the technology and lower the production costs. This would go on to cement photovoltaic technology as a reliable source of energy even outside of the space, especially during 1970s energy crisis. But really, how does it work? To answer that question, we have to know that the photons carry solar energy, and the sunlight is composed of photons or particles of solar energy. These photons contain varying amount of energy that correspond to different wavelengths of the solar spectrum. And this is the operation of the basic photovoltaic, or we call it a PV cell, and also a solar cell. Solar cells are made of the same kind of semiconductor materials such as silicon, used widely in the microelectronics industry. For a solar cell, a thin semiconductor wafer is specially treated to form an electric field, positive on one side and negative on the other side. When the light energy strikes the solar cell, they may be reflected off the cell, passes through the cell, or absorbed by the semiconductor material. And only the absorbed photons or light energy provide energy to generate electricity. When the semiconductor material absorbs enough sunlight or solar energy, the electrons inside them can be knocked loose from the atoms in the semiconductor material, and thanks to the special treatment of the material surface during manufacturing, which making them the surface of the cell more receptive to the knocked loose electron, or we call it as free electrons, so that the electron naturally migrated to the surface of the cell. Now, let's talk about the flow of electricity in a PV system. From previous, we knew that there are free electrons, and each of them carrying negative charge towards the front surface and creating the imbalance of electrical charge between the cell front and also back surface. This imbalance in turn will create a voltage potential like the negative and also positive terminal of the battery. Electrical conductor on the cell absorb electrons. if electrical conductors are attached to the positive and negative side, forming an electrical circuit, this electron can be captured in the form of electric current, that is electricity. This electricity can then be used to power a load, such as the light or a tool. To increase the production of electricity of PV system, there are two main innovative have been made, from the inside of the cell and also outside of the cell. First, let's deep into the PV cell. Today, most common PV devices use a single junction or interface to create an electric field within a semiconductor such as the PV cell. In a single junction PV cell, only the photons whose energy is equal or greater than the band gap of the cell material can free an electron for an electrical circuit. And in other words, the photovoltaic response of a single junction cell is limited to the portion of the sun spectrum whose energy is above the band gap of the absorbing materials, and lower energy photons are not used. Let's talk about the advantage of photovoltaic. The efficiency at which a photovoltaic system converts the sunlight into electricity can vary, but generally speaking, the main factors are the type of semiconductor material and the photovoltaic cell technology applied. The efficiency of commercially available PV module averaged less than 10% in the mid-1980s, and now is approaching 20% for state-of-the-art modules. Niche market and experimental PV cells are now capable of reaching an efficiency of 50%, even though time can only tell when the technology will be available to the general public. As with everything, there are some disadvantages that come with it. Most notably, it comes with a heavy reliance on technological development. The PV industry and the generation of electricity with PV system highly depends on the development of the solar technology, especially the improvement of the cell's efficiency to transform the solar energy into the electricity. In addition, the implementation of the PV in household can be quite taxing, as it will cost up to tens of thousands of ringgit. This is because expensive high technology, large amount of rare materials, highly skilled and also expensive construction personnel are needed to build and operate the PV system. Thus, the cost of PV's installation must be continued to drop for it to become widely used energy resources. So, what can we conclude about this? As based on the pre-existing research, it is clear that the solar energy is regarded as a renewable energy resource that holds untapped potential. And with further research, it has a chance to be at the forefront of the effort to reduce the carbon emission and also curb climate change. And perhaps in a few years, having a PV cells at home will be as common as installing a new bulb. Well, I'm looking forward for that, so I no need to pay for my electricity bill anymore.